Welcome to another tutorial on Matlab. In this particular series, we are looking into the concept of plant modeling and how to implement the same in Simulink plus Matlab environment. In the previous tutorial, we have seen how to implement plant models in the Simulink environment. In these videos, we are looking into how to implement the same in a Matlab environment. Matlab environment basically represents the coding approach, which is the scripting approach through which we will be creating all these plant model, and this will be more helpful to understand and analyze the system in a deeper way. In this particular tutorial, we are looking into the real world scenarios, like suppose there is a train which is moving and how the forces acts on the bogies, like how the forces are acting on these bogies and how they are behaving based on the motion of the train. So if you see a real train, then you will be able to see one engine box or an engine compartment and one or several the bogies. So there will be different bogies, B1, B2, B3, and these bogies will be moving along with the train engine. So when the train engine moves, it will exert some force F on these bogies and the bogies will start moving. So you can see there is an elastic part, or there is a material or some metallic part which has some elasticity and which will be able to hold the bogies together or with the compartment, engine compartment, to move the train in a smoother way. So let's jump into a reduced figure for this particular train model to have a simpler and detailed understanding on the same. So to see a reduced model, we will have only the engine, and which will have also some mass, and we will have a bogie. So we are considering only one bogie in this case, and based on this we will be creating the free body diagram and also a short block formatted diagram, which will be helpful for us to understand in a deeper way how the forces are acting on the individual bodies. So let's see that. So if you see here now, then you can see the engine will have some mass, which is m1, and the bogie will have some mass which is m2. So these are the two masses that are present in this particular diagram, and we have reduced it to a block diagram so that it will be more simpler to understand. So this is the force that will be moving the engine, and the force is coming from the engine itself, and the mass m1 will be moving with the help of this force, and the displacement, suppose in that case, is x1 for mass m1, and for m2 it is x2, and the joint that is existing here is replaced with a spring equivalent to spring and will have some spring constant. With the help of this, we can also predict like the force which is also related to the rolling friction. So this is related to the rolling friction or the friction force that is acting on the particular body, and it also depends on the rotational speed or the velocity of the masses, so m1 and m2. So here we can reduce these blocks into the free body diagrams for mass m1 and m2. So this is m2, and the force applied is F, and there is an extension that will be created in the spring due to the relative motion, so which will help in expanding the spring, and that will reserve the force inside the spring, and that is a resultant of these two displacement. So these two displacement will be subtracted, and you will get the force for both the components. So for m1 and m2, this is in a positive direction, this is in a negative direction. Along with that, you will be also getting the b1 and b2 as the forces for the friction, and here the displacement of m2 is x2, and based on that we will be creating and writing the equilibrium equation for both of the system. Now suppose this free body diagram we have now reduced to a system equation. So let's understand the system equation. Here mass m1 is moving with a acceleration a1 or x1 double dot. So this could be representing the acceleration of the mass m1. So here we are creating the F equal to ma, which is the Newton's second law part. So here we are balancing the force on the right hand side. So what are the forces acting on the mass m1? Force F, which is this one, and the spring force that is acting here, and the frictional force that is acting on the reverse direction of the motion, because the motion is in this direction and the friction will act on the reverse direction. So this is the component for the friction, rolling friction, which is related to the velocity. And then for mass m2 we have the part which is representing m2 into acceleration of m2, which is the mass into acceleration, which is equivalent to the spring constant into displacement, relative displacement that is created, plus minus the friction force that is acting on this particular body. So this is the system equations for the entire system. Now we can reduce this entire system into a state space model. The system equation can be reduced into the state space model. So here dx1 or x1 represents the displacement of the first body, which is mass m1. v1 represents the velocity of the first body. x2 represents the displacement of the second body, which is mass m2, and v2 represents the velocity of the second body, which is mass. And here we can correlate it like dx1 by dt equal to, so velocity, you can multiply this is the second term, so you can multiply this with the second term and you will get the velocity. The same way you will get dx2 by dt equal to, so these are the equations which are representing the individual lines here. So this is the second line, this is the fourth line, this is the first line, and this is the third line. So 1, 2, 3 and 4. So this is ax plus bu, x dx by dt equal to ax plus bu, and here this is the dx by dt part, and this is A matrix, and this is matrix X, which is the state vector. This is state transition matrix, this is input matrix, and this is the input. So these are the components. So B is the input matrix and F is the input. The below one represents like what is the things that you want to have as output. So here the below equation represents that we want to measure only the velocity of the first block. So suppose if you want to measure other parameters also, then you will have to make these things as one. So whichever the things that you want to make one, that you can change, and you will get the y defined in that way. So this is called output equation, which looks like c into x plus d into u. So these two equations altogether represents any system in a state space representation, and this is called the output equation, and this is called the state equation. So this is the state equation and this is the output equation. In this tutorial we have seen how to develop a state space equation for a train system. In the next tutorial we will see how to develop the same state space model in a Matlab scripted environment, and we will see how it is behaving based on the input that is we are giving. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. We will be happy to clarify it as soon as possible. Have a great day and happy learning MATLAB.